This video is going to be about the physics of LEGO race cars. Here I have two LEGO cars, small car A and big car B. There are important physics concepts that apply for these two cars, in which I will demonstrate in this video. One of the key physics concepts that apply to these two cars are Newton's laws of motion and the forms of energy. Newton's first law states that an object at rest or in motion will stay in that state unless acted upon a net force. In this case, the two cars are at rest because I'm not applying any force to them. Therefore, their potential energy is zero. Going back to Newton's laws, we will now focus on the second law, which states that the net force is directly proportional to the acceleration and inversely proportional to the mass. Newton's third law states that for every action force, there's an equal yet opposite reaction force. Even though the cars differ in mass, they bounce off when in contact with each other, which is displayed when I push on the big car and pull back on the small car in order for them to collide. In addition, as the force of the car's tires push down onto the floor, the force of the floor exerts it against them. I added congruent lines on the axes to show where the contact forces were equal and opposite to each other. Small car A covers a distance of 47 inches, which is converted into 1.19 meters. Here, big car B covers a distance of 42 inches, which is converted into 1.07 meters. Here, the mass of car A is 171.4 grams, and the mass of car B is approximately 544 grams. With these given values, I can now find the kinetic energy for both of these cars. Now we can find the kinetic energies. Now in case you didn't know this, kinetic energy is the form of energy possessed by an object during the state of motion. We can find it with that equation. The kinetic energy that's possessed by big car B is about 0.012 joules. For little car A, it's about 0.05 joules. Therefore, big car B has more kinetic energy due to its larger mass. Now I'll talk about balanced and unbalanced forces. In the beginning, the force of gravity on the ramp pulls the cars downward, causing it to be unbalanced. However, the forces are balanced when gravity pulls downward on the car and the floor pushes upward on the car, which happens on and off the ramp. In other words, when these forces are balanced, the car is in a state of equilibrium. This is the force diagram for when the cars were on the ramp, and this is when they were off the ramp and on the floor.